Alright guys, so today we're going to talk about 6.4, which is the law of sines. Law of sines, I think some of you may know already. I remember covering this some in geometry a few years ago, but we'll just go over it again. There's a couple of instances where it's a little tougher than normal, so let's see what we've got here. From this point forward, whenever we label a triangle, what we're going to do is we're going to label angles with capital letters, like capital A, capital B, and capital C. And we'll label the sides with lowercase letters. So capital A is opposite of lowercase a, and capital B is opposite of lowercase b, and capital C is opposite of lowercase c. And that's kind of the standard we're going to stick to for the next for this couple of units, this couple of sections rather. So when we use the law of sines, it's used to help us find angles and sides. And the nice thing is we don't have to have right triangles anymore. So we can use it in a couple of cases. If you remember from geometry, we talked about angle, side angle, and side angle, angle, and we also talked about side, side angle. Actually, this one was the one we didn't like, but we can actually use the law of sines whenever we have triangles that fit the side, side angle profile. Here's the law of sines. It says when you have a triangle ABC, and again, that's drawn the same way that we had before, you label your angles with capital A, B, and C, and then your sides are opposite of that. So capital A is across from lowercase a, capital B is opposite lowercase b, and capital C is opposite of lowercase c. So for triangle ABC, every time sine capital A over little a is equal to sine capital B over little b, which is equal to sine capital C over little c. So really there's three pieces of this equation. Any given time, though, we're only going to need two pieces. So what we're going to do is we're going to figure out what we know, and once we do that, we'll use those two pieces. So let's try a couple of examples, and I think you'll see what I mean. So in the first example here, tracking a satellite. A satellite orbiting the Earth passes directly overhead an observation stations in Phoenix and Los Angeles, 340 miles apart. At an instant when the satellite is between the two stations, its angle of elevation is simultaneously observed to be 60 degrees at Phoenix and 75 degrees at Los Angeles. How far is the satellite from Los Angeles? In other words, find the distance AC in Figure 4. So we're trying to find how far this satellite up here is from Los Angeles. So we're trying to find A to C up here. Okay? So in doing that, what we're going to be doing then is setting up what we know. So looking at this triangle here, you're always going to know, if you can use law of sines, you should have one angle and one side that go together, one pair. So either both of the A's, both of the B's, or both of the C's. In this case, I only know one side. So I would say, well, what angle do I know? And if I look up here, I don't know the angle that goes with this, but I can find this angle because I know that angle A is 75 and angle B is 60. So if I have 75 plus 60, that's equal to 135. And if I take 180 minus 135, I'm going to be left with 45. So this angle up here is actually 45 degrees. So that's going to be the first step here. So sometimes you have to solve for that missing angle. All right, now that I know that angle and that side, I know that I'm going to use the C's, so I'm going to say I'm going to use sine C over C. Sine big C over little c is equal to, and I wanted to know what this little b is, so I'm going to do sine of big B over little b. All right, and so what I can do is plug in everything we know. Sine of big C is 45 degrees, divided by little c, which is 340, is equal to sine of big B, so that's going to be sine of 60 degrees over little b, and we don't know what little b is. So if we were going to solve this, we would cross multiply, okay? And we're going to get b times sine 45 is equal to 340 sine 60. And if I want to know what b is, I have to divide by sine 45. So you can type in this whole thing in your calculator. You got to be careful when you type it in to make sure that you have this calculation first, then divide it by this. So let me go get a calculator real quick because I forgot one. And I can type this in. So if I type in 340, first of all, we're in degrees, so make sure you're in degree mode. So 340 sine of 60 divided by sine of 45. And what we're going to get is that B is 416.41. And what were we in? We were in miles. So this is miles. And that's nice because we don't have a right triangle, but yet we're able to find that. All right, what about when we have side angle angle? So this says to solve the triangle in figure 5. Here's figure 5. We want to find out everything that we don't know. So first of all, the easiest thing is find the missing angle. So I've got 20 and 25. So 20 plus 25 is 45. 180 minus 45 is 135. So B is 135. Now I've got that. I can solve for a missing side. I get to choose really what I want to solve for. I know I have to use C and big C and little c because those are the two things I know. So we'll start with sine of big C, which is 25, divided by the side associated with that, 80.4, is equal to, okay, well, what else do I want to know? Well, I could do either side. It doesn't matter which side you do first. Let's go ahead and just do it alphabetically. We'll go for A. So we'll do sine of big A, which is 20 degrees, over little a. I don't know what little a is. Okay, now we're going to cross multiply to get A times sine 25 is equal to 80.4 sine of 20. And I can divide by sine 25 on both sides. Okay, once we do that, you're going to find out that A is equal to, because those cancels, so 80.4 times sine of 20 divided by sine of 25 is equal to 65.07. So A is 65.07. Now I know this, so what we can do is just do the exact same problem. That's part A, I guess. That gives us A. We can do the exact same thing, and I'm going to use what we were given since I already know that was definite, and I rounded this value, so I don't want to use a rounded value. So I'm going to use what was definite again. So I'm going to start with sine 25 over 80.4, because I know for sure that's what was given, that's what we know, is equal to, and then this time we'll do B, sine of big B, which is 135, over little b. And so what we're going to get when we cross multiply again, we're going to get B sine 25 is equal to 80.4 sine 135, and to find out B, we divide by sine 25. So divide by sine 25. So B is equal to 80.4 sine of 135 divided by sine of 25. And so what we're going to get then is 134.52. Okay? And that solves everything, because now I know that I know every value. I know all the sides. I know all the angles. We're done. Okay. Okay, so now we're going to talk about the ambiguous case. And the ambiguous case comes when you're solving for an angle. So if you're solving for a missing angle using this method, then what happens is sine is kind of weird, because whenever you are looking for an angle, remember, if you want to find an angle, that means you're always going to have to use sine inverse. Well, if you try and type in some things on your calculator, like inverse sine of, say, 8 over 10, any one of these numbers, no matter what you type in, you're going to get a number between 0 and 90. But the thing is we know that if you do inverse sine, we know that the angles could be anywhere from 0 to 180. So the fact that inverse sine gives you the small angle means that really every time you could have two solutions. So what could happen is the sides and angles you're given, there's actually three cases we can have. We could have this first case right here, which is where we have an angle and we're given a side, and then we're given another side, but that side is too short to reach the other side, in which case there's no solution. Okay. The second case is whenever we're given an angle and a side, and it just so happens that this third side here reaches down just perfectly and hits at this 90-degree angle. Okay? That's the second case, in which case there's one solution. The third case, and this is what we call the ambiguous case, is when this happens. Whenever you find this angle and we find out that what happens is this length could hit in two places. It could hit over here or over here. And because of that, we have this ambiguous case. Now what's going to happen is that the solutions, the angles that we find, are either going to be the complement, or they're going to be an angle and its complement. Sorry, and its supplement. Sorry, let me fix that. It's actually the supplement. So they'll always add to 180. Let's see what we're talking about here. First of all, let's check out the one solution case. So solve the triangle ABC where angle A, so let's draw a triangle first. We've got capital A, capital B, capital C, which means we've got lowercase a here, lowercase b, lowercase c. Angle A is 45 degrees. Side A is 7 radical 2, and side B is 7. Well, I know both of my A's, so I'm going to go ahead and use sine A, capital A, which is 45 degrees, over little a, which is 7 square root of 2, is equal to, the only thing I know right now is what B is, so I'm going to go ahead and use sine of big B over little b, which is 7. So I'm going to multiply both sides by 7 here, and when you do, that means we're going to have 7 times sine 45 divided by 7 radical 2. And that's going to be sine of B. So I can go ahead and evaluate that. So if I do 7 sine of 45 divided by 7 radical 2, so divided by 7 radical 2, that's going to be 0.5. So this is 0.5 is equal to sine B. Okay. So to find out what B is, we have to take the inverse sine of 0.5. And if we do that, we're going to get that B is equal to the inverse sine of 0.5, which means that B is in fact 30 degrees. Alright, so that means this is 30 degrees. But, like I said earlier, there's actually two values of sine 30 degrees here. There's actually another value over here that has the exact same y value. Remember this y value here, well, this point is radical 3 over 2, comma 1/2, and so sine of that is 1/2. This angle over here, which is 150 degrees, has the point negative radical 3 over 2, comma 1/2. So really, there's two answers. It could be 30, or it could be 180 minus 30, which is 150 degrees. So, which one is correct? And why should there only be one solution? Well, if I look at this, I've got 30 degrees as B, which I filled in here. That's okay because I've got, so far, 30 degrees times plus 45 degrees. That's 75 degrees. And so I can find out what C is. But if I thought about it as the second case, if this was 45 degrees and I said this angle was 150, 150 plus 45 is too big. It's 195, and we know that that can't happen, which means that this solution gets rejected. So what's going to happen then is we're going to use this triangle, and we can solve the rest of this triangle. So we knew what A was, so what we can do to find the rest of the solutions, we can say, okay, if I've got B here is 30, I can find C. 45 plus 30 is 75. Which means that 180 minus 75 is equal to 105. So this angle is actually 105. Not drawn to scale here, seeing as that looks acute, but it's actually a obtuse angle. So let's go ahead and from here, we can solve for C. So to do that, I'll do this over here on the left. We're going to use the same thing. We're going to use what we knew to start with. So sine of 45 over 7 radical 2 is equal to, we're going to say sine of 105 over C, little c. So cross multiply, C sine 45 is equal to 7 radical 2 sine 105. And so we can find out that when we divide by sine 45, that C is equal to this value right here. Sorry, it's a little cluttered there. So let's try that. 7 radical 2, make sure you close out your parentheses, times sine 105 divided by sine of 45 is equal to 13.52. So 13.52. There we go, we have our answer. In the two solution case, we're going to have a triangle. Let's call this A, maybe we'll call this B, we'll call this C. This B's a little messy, there we go, it looks more like a B. This is little b, this is little a, this is little c. We know that this is 43.1, and we also know that we've got little a is 186.2, and we know that little b is 248.6. 248.6. Alright, so what we can do then is we can take this, and we know that if we do, let's see, what do we got here? We've got both the a's, so we can do sine a over a equals sine of big B over B. And so sine of 43.1 over 186.2 is equal to sine of big B over little b, which is 248.6. So if we multiply both sides by 248.6, then this will cancel. We'll be left with sine of b is equal to, let's see, 248.6 here. So that's going to be 248.6 times sine of 43.1 all over 186.2. That's what sine b is. So we'll calculate that, and we get the sine b is equal to, let's see, 248.6 sine of 43.1 divided by 186.2. That's going to be 0.9122548888. And if you do inverse sine of this, so inverse sine of that number, then you'll get what b is. So doing inverse sine here cancels out everything. We get b is equal to the inverse sine of that answer, which is 65.8. Or, we learned earlier we have to look at the supplement. So we do 180 minus 65.8, and that's going to give me the other possibility. So in this case, 180 minus 65.8 is going to be 114.2. So if I look up here, that means angle B could be this angle, or it could be this angle. So we have to check and see if both of those work. So if I do 43.1 plus 65.8, then you're going to get 108.9, 108.9, which works because this is less than 180 degrees. So now if you do 180 minus 108.9, you're going to get 71.1 degrees, which means that this could be 71.1 degrees. So now we can solve for side C. We're going to come over here in a few minutes and do this particular problem too, because we also know now that, let's see, this is 43.1, this was 248.6, and this one was 186.2. We said maybe this could be 114.2. Well, if you do 43.1 plus 114.2, that's equal to 157.3. And sure enough, that's less than 180 as well. So we can do 180 minus 157.3 to figure out that this other angle could be 22.7 degrees. So this works as well, 22.7. And so what we're going to have to do is find out what this C is as well. We'll start over here. We'll do sine C over C is equal to sine A over A. I should have started with sine A over A, but that's all right. We can do it backwards. Sine C here is going to be sine of 71.1 over C is equal to sine of 43.1 over 186.2. We're going to cross multiply here to get that 186.2 sine 71.1 is equal to C times sine of 43.1, and we can divide by sine of 43.1 on both sides to get our answer. So divide by that. We type it in our calculator. When we do 186.2 times sine of 71.1 divided by sine of 43.1, we get our answer to be 257.8. So that's our C value there. In the other case, we do the same thing. We do sine A over A. So remember, this was labeled A, B, and C. So if we do sine big A over little a, that's equal to sine of big C over little c. And so we get sine of 186.2 all over 43. Oops, I did that incorrect. Let's try that one more time. Let's do sine of 43.1 over 186.2 is equal to sine of big C, that's 22.7 over little c. And when you cross multiply these, you're going to get C times sine of 43.1 is equal to 186.2 times the sine of 22.7. So when you divide by this, 43.1 divide by sine 43.1, you're going to get these cancel. C is equal to 186.2 times sine 22.7 divided by sine 43.1. And so C is equal to 105.1. Well, 0.2. It rounds to 0.2. So these are both solutions to this particular case. So in this example, there are actually two triangles that satisfy this, and here they are. All right, the no solution case. This is the easy one. So if I have a triangle, we'll do the same thing, A, B, and C. Then this is little a, this is little b, this is little c. And we know this is 42 degrees, a is 70, and b is 122. Well, we can say that sine of big A over little a is equal to sine of big B over little b. Well, whenever we plug things in, we get sine of 42 over a, that's 70, is equal to sine of big B over little b, which is 122. If we multiply both sides by 122, these would cancel. We get sine of b is equal to 122 sine 42 all over 70. Well, when you calculate that, 122 sine of 42 divided by 70, you are going to get 1.166199057, and that is sine b. Well, if we do the inverse sine of both sides, so inverse sine here of both sides, well, what happens? These cancel. We're left with b is equal to. Whenever you try and do that in your calculator, you're going to be surprised because you're going to get this error message. This can't happen. There's no solution. The reason this can't happen is because in order for sine of b to be this value, that means that if you think about your unit circle, that means that the y value would have to at some point reach 1.16, but the highest that the unit circle goes is 1. So anytime you get this number bigger than 1 equal to sine b, or sine of an angle, you know that that can't happen, and so you have no solution. So that pretty much wraps it up, guys. Those are the cases we deal with. Hope you don't have too many questions about it. We'll try this tomorrow, and we'll give it a go. Have a good evening.